Tonight, we're diving into the hidden mysteries of the ocean, a world filled with ancient creatures, lost places, strange sounds, and secrets humanity still hasn't fully explained. So relax, get comfortable, and let the deep sea slowly carry you away tonight. Before we begin, leave a comment below telling me what city you're watching from and what mystery you'd like me to explore next. And if you enjoy documentaries like this, don't forget to subscribe. Sleep well and enjoy the journey into the unknown. The deeper you go into the ocean, the less Earth feels like home. Sunlight fades surprisingly fast beneath the surface, disappearing layer by layer until the water turns black enough to erase every sense of distance and direction. Most people imagine the ocean as blue, open, and alive with movement. But almost all of the ocean actually exists in darkness, cold darkness, silent darkness. A place where pressure becomes so powerful that even steel begins to struggle against it. And despite satellites, sonar systems, and decades of scientific exploration, humanity still knows remarkably little about what truly exists below. One of the strangest facts about Earth is that humans have mapped parts of Mars and the Moon in greater detail than huge portions of the seafloor. That sounds impossible at first, but the ocean hides itself incredibly well. Space may be hostile, but at least telescopes can see through it. The deep ocean buries everything beneath miles of moving water. Sonar ships must travel slowly across enormous distances, scanning tiny sections at a time. Even now, large areas of the seafloor remain blurry, incomplete, or completely unseen. There are places on this planet where no human eyes have ever looked directly, not because they are far away, but because they are hidden beneath crushing water. And nowhere represents that hidden world more than the Mariana Trench. Located in the western Pacific Ocean, this trench cuts downward nearly 7 miles beneath the surface. At its deepest known point, Challenger Deep, the pressure becomes almost difficult to imagine. Every square inch experiences thousands of pounds of force. If a normal submarine descended there, it would collapse instantly. Even specially designed deep-sea vessels creak and flex under the strain. The ocean at that depth no longer feels like ordinary water. It behaves almost like a physical wall, pressing inward from every direction at once. Yet something even stranger waits there. Life. For a long time, many scientists believed the deepest ocean floors might be mostly barren, too cold and too pressurized to support complex organisms. But expedition after expedition proved otherwise. Tiny crustaceans crawl across the trenches. Transparent sea cucumbers drift through black water. Fish with soft bodies survive in places where the pressure should theoretically crush ordinary biology. Somehow, evolution adapted to conditions that sound almost impossible. In the deepest ocean, survival stopped depending on strength or speed and became a question of endurance. Everything there moves slowly, wastes little energy, and survives in ways that seem almost alien. As sunlight disappears, the ocean enters what researchers often call the midnight zone, a region so dark that day and night become meaningless. No sunrise has ever touched those waters. No natural beam of light has traveled there from the surface. The deeper you descend, the more the ocean resembles outer space. Temperatures hover near freezing. The blackness becomes absolute. Human instincts depend heavily on visible horizons and reference points, but the deep ocean removes them completely. Submarine pilots sometimes describe a strange psychological effect during long descents, a sensation that the world above has vanished entirely. And then, unexpectedly, the darkness begins to glow. Some of the most mysterious creatures in the deep sea produce their own light through bioluminescence. Tiny blue flashes drift through the water like underwater stars. Jellyfish pulse with glowing rings. Fish carry natural lanterns attached to their heads to lure prey closer in darkness. Scientists believe this adaptation evolved for many reasons: hunting, communication, camouflage, even defense. In some areas of the deep ocean, bioluminescent flashes appear so frequently that the darkness almost feels alive. Ancient sailors who witnessed glowing oceans during storms often believed they were seeing supernatural forces. In reality, many of those glowing waves likely came from microscopic organisms reacting to movement in the water. But even stranger than the creatures themselves is how little humans still know about them. Many deep-sea species have been observed only once. Some were discovered accidentally in fishing nets before disappearing from scientific observation again. Entire ecosystems may exist untouched because reaching them remains so difficult and expensive. Every deep-sea expedition operates under severe limitations. Batteries fail, cameras freeze, pressure destroys equipment. Sometimes, researchers spend years planning missions that last only a few hours once the submarine reaches the bottom. The ocean floor itself is equally mysterious. Beneath the water are mountain ranges longer than any on land. Massive underwater ridges wrap around the planet like hidden scars across Earth's crust. Some trenches are deeper than the Grand Canyon by several times. Volcanic systems erupt continuously beneath the ocean without most people ever realizing it. In fact, the longest mountain chain on Earth is underwater. It stretches for tens of thousands of miles across the sea floor, almost completely invisible to daily human life. And still, there are gaps in our knowledge large enough to disturb scientists themselves. Researchers sometimes refer to sections of the ocean as data deserts, regions where mapping information remains sparse or outdated. Certain remote parts of the Pacific and Southern Ocean are so difficult to scan thoroughly that modern maps still contain major uncertainties. It is entirely possible that large geological structures remain undiscovered simply because nobody has looked closely enough yet. That idea feels almost unbelievable in the age of smartphones and satellites. But the ocean continues to resist complete observation. The deeper humanity explores, the stranger the sounds become as well. Hydrophones placed in the ocean have recorded noises powerful enough to travel thousands of miles underwater. Some come from earthquakes or underwater volcanic eruptions. Others originate from shifting ice near Antarctica. But not every sound has been immediately understood. One famous example known as the bloop, triggered years of speculation after scientists detected an ultra-low frequency sound echoing across the Pacific Ocean. Its source was never visually confirmed. Many researchers later suggested cracking Antarctic ice as the most likely explanation, though the mystery captured public imagination because it revealed something unsettling. The ocean still produces phenomena that science cannot instantly identify. Part of what makes underwater sound so eerie is the way the ocean carries it. Sound travels far more efficiently underwater than through air. Whale calls can move across entire ocean basins. Mechanical noises from ships echo through darkness for enormous distances. In some regions, the deep ocean becomes a world defined more by sound than sight. Creatures communicate through vibrations humans rarely notice from the surface. Hidden below the waves is an invisible acoustic landscape, constantly moving through darkness. Reaching these depths requires extraordinary machines. Deep-sea submarines are engineered more like armored spheres than ordinary vehicles because rounded structures distribute pressure more safely. Every descent is risky. One tiny structural flaw can become catastrophic in seconds. Inside these vessels, explorers often sit cramped in near darkness for hours while descending through endless black water. Outside the small viewing ports, nothing appears except floating particles illuminated by artificial light. Then, suddenly, after miles of descent, the seafloor emerges from darkness like another planet. Some explorers describe that first sight as emotionally overwhelming, not because of danger alone, but because of isolation. At the bottom of the ocean, humans are farther from normal life than almost anywhere else on Earth. There are no rescue teams waiting nearby, no sunlight, no quick return, only black water stretching upward for miles. It creates a strange awareness of how thin human survival really is. And even after all these expeditions, scientists still debate how much remains undiscovered. Some researchers believe thousands, possibly millions of marine species are still unknown to science. Others suspect unexplored trenches may contain geological formations unlike anything yet documented. There are even discussions about whether unknown microorganisms deep beneath the seafloor could reshape our understanding of how life survives in extreme environments. The ocean continues forcing science to stay humble. Perhaps that is what makes the deep sea so fascinating. It is one of the last places on Earth where genuine mystery still survives. Most of the planet's surface has been photographed, traveled, mapped, and analyzed. But beneath the ocean, enormous sections remain hidden in darkness, exactly as they were long before human civilization existed. Somewhere tonight, miles below the surface, strange creatures drift through trenches no person has ever seen directly. Mountains rise unseen beneath black water. Unknown sounds move slowly through the cold, and the deeper humanity looks, the more the ocean seems to whisper the same unsettling truth. This world is still far less explored than we like to believe. If someone had described the deepest creatures of the ocean before modern science existed, most people would have assumed they were inventing monsters. Fish with transparent heads, predators carrying glowing lights on their faces, creatures with teeth too large for their own mouths, animals capable of surviving pressures that would crush steel machinery. Yet nearly all of them are real. And the deeper humanity explores the ocean, the more the line between biology and nightmare begins to blur. One of the strangest truths about life beneath the sea is that evolution followed completely different rules there. Near the surface, survival often depends on speed, vision, camouflage, or strength. But in the deep ocean, sunlight disappears, food becomes rare, and the environment grows so hostile that many species evolved in ways that seem almost impossible compared to life on land. In darkness that has lasted millions of years, nature stopped caring about appearances. It became obsessed only with survival. Few creatures represent this better than the anglerfish. Floating through black water thousands of feet below the surface, the female anglerfish carries a glowing lure extending from her head like a living fishing rod. In darkness so complete that eyesight becomes almost useless, this tiny light becomes deadly. Smaller fish drift toward the glow, mistaking it for food or safety, only to disappear inside enormous jaws lined with transparent, needle-like teeth. The deeper researchers study anglerfish, the stranger they become. In some species, the males are tiny compared to females, sometimes little more than drifting parasites. Once a male finds a female, he may physically fuse into her body, losing his independence completely and surviving only to provide reproduction. It sounds less like ordinary biology and more like something imagined for science fiction. And yet, the anglerfish is far from the strangest thing in the ocean. In some deep regions of the Pacific, scientists discovered fish with transparent skulls, allowing researchers to see parts of the animal's internal structure directly through its head. One species, commonly called the barrel eye fish, has upward-facing eyes enclosed beneath a clear, protective dome. For years, scientists misunderstood how the animal even functioned because damaged specimens distorted its appearance once brought to the surface. Only modern deep-sea cameras revealed how bizarre the creature truly looked, alive in its natural environment. It spends much of its time staring upward into darkness, searching for faint silhouettes drifting far above. That upward gaze appears again and again in deep-sea life. Many predators evolved oversized eyes designed to capture the smallest possible traces of bioluminescent light. Others abandoned vision almost entirely, relying instead on pressure changes and vibrations moving through water. In the deep ocean, hearing and sensing movement often matter more than seeing. It creates an ecosystem where creatures can feel almost ghost-like, appearing suddenly from darkness before disappearing again into black water. Then there are the giant squid. For centuries, sailors told stories about enormous, tentacled creatures rising from the sea, wrapping around ships, and vanishing beneath storms. Most scientists dismissed these stories as exaggerations fueled by fear and isolation at sea. But eventually, physical evidence became impossible to ignore. Massive squid carcasses washed ashore. Scars on sperm whales suggested violent underwater battles against giant tentacles. And in the early 21st century, researchers finally captured rare footage of giant squid alive in the deep ocean. Even now, giant squid remain deeply mysterious because humans almost never encounter them naturally. They live at depths difficult to study and seem capable of detecting approaching disturbances long before cameras arrive. Some estimates suggest giant squid can reach lengths over 40 feet when including tentacles, though precise measurements remain debated because many specimens are damaged before recovery. What makes them especially unsettling is not just their size, but the fact that such enormous predators managed to remain largely hidden from direct human observation for so long. It raises an uncomfortable possibility. If something that large can avoid us in the deep ocean, what else might still remain unseen? Some deep-sea creatures evolved bodies so fragile they barely seem real. Transparent jellyfish drift through darkness like living glass sculptures. Certain species are almost invisible except for faint glowing organs pulsing inside their bodies. Others evolved soft, gelatinous forms because heavy skeletal structures become inefficient under crushing pressure. The deeper the ocean becomes, the stranger the rules of life appear. And then there is bioluminescence, perhaps the ocean's most alien phenomenon of all. In the deepest waters, countless species generate their own light chemically. Some flash blue when threatened, others pulse rhythmically to communicate. Certain predators use glowing bait to lure prey closer. Scientists believe bioluminescence evolved independently many different times across ocean life, meaning nature repeatedly arrived at the same solution in darkness. If sunlight disappears, organisms create their own stars. There are moments during deep-sea expeditions when submarine lights are turned off entirely. Pilots describe watching tiny flashes ignite across the darkness around them like underwater galaxies. Creatures invisible seconds earlier suddenly reveal themselves through glowing signals drifting slowly through black water. It changes the emotional feeling of the ocean. The deep sea no longer seems empty. It seems inhabited by life forms, operating according to rules humans barely understand. Among the strangest marine animals ever discovered is the Greenland shark, a slow-moving predator living in Arctic waters. Unlike fast, aggressive sharks portrayed in movies, Greenland sharks move almost lazily through freezing darkness. But what shocked researchers most was not their behavior, it was their age. Some studies estimate these sharks may live for several centuries, potentially making them among the longest living vertebrates on Earth. One shark examined by scientists may have already been alive when Galileo was studying the night sky. Because these sharks grow extremely slowly in cold environments, they exist almost outside normal human concepts of time. And perhaps nowhere does ocean life become more unsettling than with creatures scientists barely understand at all. Each year, fishing nets accidentally pull unknown organisms from extreme depths. Some are too damaged for proper identification. Others belong to species never previously documented. Researchers estimate that vast numbers of marine species remain undiscovered, especially in the deep ocean, where exploration remains limited. Entire branches of life may still exist beneath thousands of feet of water, surviving unnoticed simply because humans have not searched those regions carefully enough. This becomes even more fascinating when considering Earth's history. Long before humans existed, the oceans belonged to creatures far stranger and often far larger than anything alive today. Ancient marine reptiles once dominated prehistoric seas. Massive armored fish hunted in waters where early sharks evolved. Some prehistoric oceans contained predators large enough to swallow modern animals whole. The ocean has always rewarded adaptation, and over hundreds of millions of years, it produced forms of life so bizarre that many sound fictional even now. The megalodon remains one of the most famous examples. Although scientists continue debating details about its behavior and exact size, most evidence suggests this ancient shark was truly enormous, potentially reaching lengths far beyond modern great white sharks. Fossilized teeth the size of human hands continue fueling public fascination because they hint at a predator almost difficult to visualize realistically. There is no scientific evidence that Megalodon still survives today, despite internet myths and sensational documentaries. But the persistence of those theories reveals something deeper about human psychology. The ocean is vast enough that people instinctively feel something enormous could still be hidden there. And honestly, that feeling is not entirely irrational. Even now, researchers regularly discover species larger, stranger, or more complex than expected. Some deep-sea squid can change color instantly across their bodies using specialized skin cells. Certain octopuses demonstrate problem-solving abilities that continue surprising scientists. Mantis shrimp possess one of the most powerful strikes in the animal kingdom, accelerating their limbs so fast they create tiny shock waves underwater. Nature beneath the ocean repeatedly evolves abilities that seem almost unreal. Perhaps the strangest thing about marine life is how often it forces humanity to reconsider what survival itself means. Creatures exist without sunlight, without stable temperatures, sometimes without oxygen-rich environments. Entire ecosystems gather around hydrothermal vents deep beneath the sea, where superheated chemicals pour from Earth's crust. Instead of depending on sunlight like surface ecosystems, some organisms rely on chemical reactions for energy. Before these systems were discovered, many scientists assumed such environments could not support complex life. The deep ocean proved otherwise. That discovery changed more than marine biology. It reshaped theories about life beyond Earth. If organisms can survive in darkness, beneath crushing pressure, around volcanic vents deep underwater, then perhaps life could exist in hidden oceans beneath icy moons elsewhere in the solar system. In a strange way, the creatures living in Earth's deepest waters may represent the closest thing humans have ever found to alien life without leaving the planet. And still, despite everything already discovered, the ocean continues withholding its secrets. Somewhere tonight, beneath miles of black water, unknown species drift through darkness, untouched by sunlight and unseen by human eyes. Predators hunt silently through freezing currents. Tiny flashes of blue light pulse through trenches older than human civilization itself. The deeper humanity explores the sea, the harder it becomes to believe we truly understand the planet we live on. The ocean has always been the easiest place on Earth for something to disappear. Long before satellites, radar, or modern navigation existed, sailors crossed enormous distances guided only by stars, currents, and instinct. If a ship vanished in the middle of the Atlantic centuries ago, there was often no wreckage, no survivors, and no explanation. The sea simply closed over the story and kept moving. Even today, despite all modern technology, the ocean still hides things with unsettling efficiency. Aircraft vanish. Signals stop abruptly. Ships drift empty across open water. And beneath all of it is a simple truth that makes every mystery feel larger. Most of the ocean remains unseen. Perhaps no ocean mystery became more famous than the Bermuda Triangle. Stretching loosely between Florida, Bermuda, and Puerto Rico, this region gained worldwide attention after a series of disappearances involving ships and aircraft during the 20th century. Newspapers turned the area into legend. Stories spread about compass failures, sudden storms, unexplained radio silence, and entire crews vanishing without trace. Some writers blamed alien activity. Others imagined underwater civilizations or strange magnetic anomalies hidden beneath the Atlantic. But the reality is more complicated, and in some ways, more fascinating. The Bermuda Triangle sits in one of the busiest shipping regions on Earth. Enormous numbers of ships and aircraft have crossed it for centuries, which naturally increases the number of accidents recorded there. The area is also vulnerable to rapidly changing weather. Tropical storms can form quickly, ocean currents move aggressively, and shallow reefs create dangerous navigation hazards. Many researchers argue the mystery comes less from supernatural causes and more from how humans interpret incomplete information. Yet, even if most disappearances have logical explanations, the emotional power of the Bermuda Triangle never fully faded. It revealed something important about the ocean. When visibility disappears and evidence sinks into miles of water, uncertainty grows almost automatically. That uncertainty becomes even stranger when abandoned ships appear with nobody aboard. Throughout maritime history, sailors occasionally encountered vessels drifting silently across open water, perfectly intact, yet eerily empty. These became known as ghost ships. One of the most famous examples was the Mary Celeste, discovered in 1872, floating in the Atlantic Ocean with its cargo untouched, supplies still aboard, and no obvious sign of violence. The crew had vanished completely. Lifeboats were missing, suggesting the crew may have abandoned ship. But exactly why remains debated even now. Some historians believe rough weather or mechanical concerns triggered panic. Others suggest fumes from industrial alcohol cargo may have convinced the captain an explosion was imminent. But because no final evidence survived, the story remained suspended between logic and mystery. And the ocean seems uniquely designed to preserve that ambiguity. Storms erase evidence quickly. Salt water corrodes metal. Currents scatter debris across enormous distances. Even modern aircraft crashes can become nearly impossible to reconstruct if wreckage sinks deep enough. When Malaysia Airlines Flight 370 disappeared in 2014 over the Indian Ocean, the scale of the search operation shocked the world. Despite satellites, sonar scans, underwater drones, and international cooperation, the aircraft itself was never fully recovered. The ocean once again demonstrated how easily it can absorb something massive and leave behind only fragments. Then there are the sounds. Far beneath the surface, hydrophones constantly monitor underwater noise traveling through the oceans. Some sounds come from whales communicating across incredible distances. Others originate from earthquakes or underwater volcanic eruptions. But occasionally, researchers detect noises that do not fit expected patterns immediately. One of the most famous was the mysterious sound nicknamed the bloop, an ultra-low frequency signal detected across the Pacific Ocean. Its volume suggested something extraordinarily large or energetic. For a while, speculation exploded online. Some imagined unknown sea creatures bigger than blue whales. Others connected it to hidden underwater activity no one understood. Most scientists now believe the sound likely came from cracking Antarctic ice, and later recordings supported similar explanations. But what made the bloop so memorable was not the sound itself. It was the brief moment when humanity realized the ocean could still produce something globally recognized, yet instantly unexplained. In modern life, people are used to immediate answers. The ocean still refuses to provide them. Sometimes the mysteries are visible instead of audible. In 1986, divers exploring waters near Yonaguni Island in Japan discovered enormous underwater stone formations rising from the seafloor. The structures looked startlingly artificial at first glance. Sharp angles, flat terraces, step-like patterns descending beneath the ocean. Some researchers proposed they may be remnants of a lost human settlement submerged thousands of years ago when sea levels were lower. Others argued the formations are natural sandstone structures shaped by fractures and erosion over long periods of time. The debate continues because the site sits in an uncomfortable space between geology and archaeology. Certain features genuinely resemble carved architecture. Others appear consistent with natural rock formation processes. The more carefully researchers study the structures, the harder simple answers become. And perhaps that uncertainty explains why underwater ruins fascinate people so deeply. The ocean hides history so effectively that even discovering something ancient does not guarantee understanding it. The same feeling surrounds countless sonar anomalies discovered across the seafloor. Modern mapping technology occasionally reveals shapes difficult to explain immediately. Circular depressions, symmetrical patterns, unusual shadows beneath sediment. In most cases, later investigation produces natural explanations, but not always right away. Deep water complicates everything. Distances distort perspective. Sediment buries details. Cameras struggle in darkness. The ocean constantly creates moments where the human brain sees order, meaning, or design before science fully catches up with evidence. That tendency becomes even stronger when navigation itself begins behaving strangely. For centuries, sailors feared regions where compasses drifted unpredictably or storms appeared without warning. In reality, magnetic variation exists naturally across Earth, and navigational instruments have always required careful interpretation. But before modern understanding of geomagnetism, a spinning compass needle in open ocean could feel terrifying. Imagine standing on a wooden ship surrounded by fog with no visible land, no GPS, and an instrument suddenly refusing to behave normally. It is easy to understand how legends formed, and the ocean does not need supernatural forces to become deadly. Rogue waves alone may explain some historical disappearances once blamed on myths. These enormous waves can appear unexpectedly even in relatively calm seas, reaching heights capable of damaging large ships severely. For years, some scientists questioned whether rogue waves were truly as extreme as sailors described. Then, satellite measurements and direct observations confirmed they were real. In other words, certain sea legends turned out to contain more truth than people assumed. But perhaps the strangest thing the ocean hides is silence. There are regions underwater where sound behaves unusually because of temperature layers, pressure, and geography. Certain areas absorb or redirect acoustic energy in strange ways. Divers sometimes describe moments where familiar underwater noise suddenly disappears, replaced by an unsettling stillness. In the deep sea, silence does not feel peaceful. It feels unnatural, almost heavy. Human beings evolved in environments filled with constant sensory feedback. The ocean can remove that feedback completely. That psychological effect matters more than many people realize. Isolation changes human perception. Sailors alone at sea for weeks often reported seeing shapes, lights, or distant vessels that later vanished. Sleep deprivation, storms, darkness, and stress distort judgment even today. Some historical mysteries may have emerged partly because the ocean pushes the human mind into unfamiliar territory. Yet dismissing every strange account as imagination also feels incomplete. The sea is simply too large and too poorly observed for total certainty. Even now, researchers continue discovering shipwrecks lost for centuries beneath layers of sediment. Entire fleets vanished during storms and remained hidden until modern sonar located them accidentally. Some wrecks sit perfectly preserved in cold, deep water, frozen in time, with cargo still inside. Others disappeared so completely that historians know them only through written records. Somewhere beneath the ocean tonight are likely thousands of ships humanity has never rediscovered. And perhaps that is what separates ocean mysteries from almost every other mystery on Earth. The evidence rarely stays visible. Forests eventually reveal ruins. Deserts uncover buried cities. But the ocean swallows. It hides objects beneath darkness, pressure, and movement so effectively that even modern technology struggles to retrieve answers once something sinks deeply enough. That hidden quality changes the emotional atmosphere of every mystery connected to the sea. A missing aircraft over land feels temporary. A missing ship in the middle of the Pacific feels permanent. And still, despite centuries of exploration, the ocean continues producing moments that science cannot explain immediately. Strange lights appear beneath waves. Unidentified sounds echo through trenches. Ancient formations emerge from darkness, only to trigger new arguments rather than clear conclusions. Sometimes, the ocean reveals just enough information to deepen the mystery instead of solving it. Maybe that is why people remain obsessed with what lies beneath the surface. The ocean is one of the few places left on Earth where uncertainty still feels genuinely alive. Somewhere tonight, far below passing ships and moonlit waves, wrecks rest untouched in darkness. Unknown sounds travel silently through cold water. Ancient structures wait beneath sediment, and enormous spaces remain completely unseen by human eyes. The deeper humanity searches the ocean, the more it begins to feel less like a place we understand and more like a place that simply allows us to visit briefly before hiding its secrets again. Most people think weather is controlled by the sky. Storm clouds, winds, heat waves, hurricanes, all of it appears to come from above. But far beneath the surface of the ocean, enormous rivers of moving water are constantly shaping the climate of the entire planet in ways most people never see. Some currents travel for thousands of miles without stopping. Others sink slowly into darkness and move through the deep ocean for centuries before rising again somewhere else on Earth. Together, they form a hidden circulation system so massive that if it changed even slightly, entire regions of the world could become colder, drier, stormier, or nearly unrecognizable. One of the strangest things about ocean currents is how invisible they feel from the surface. A person standing on a beach sees waves moving toward shore and assumes the ocean itself is mostly still underneath. In reality, the water is constantly moving. Warm water flows north. Cold water sinks south. Salty water behaves differently from fresh water. Temperature, wind, Earth's rotation, and even melting ice all interact together in ways so complex that the ocean begins to resemble a living machine, quietly regulating the planet. Perhaps no current demonstrates this more clearly than the Gulf Stream. Beginning near the Gulf of Mexico, this powerful flow of warm water travels along the eastern coast of the United States before crossing the Atlantic Ocean toward Europe. It carries enormous amounts of heat with it, functioning almost like a giant conveyor belt inside the sea. Without the Gulf Stream, much of Western Europe would likely be far colder than it is today. Cities like London sit surprisingly far north compared to many parts of North America, yet their winters are often milder than places in Canada, located much farther south. The ocean helps create that difference, and that realization changes how the planet feels. Climate stops seeming local. Suddenly, warm water leaving Florida influences temperatures thousands of miles away across another continent. The deeper scientists studied these currents, the stranger the system became. Beneath the visible surface, circulation exists something even larger. A slow-moving global network, often called the thermohaline circulation, sometimes nicknamed the ocean conveyor belt. This system connects oceans across the planet through differences in temperature and salinity. In polar regions, cold, salty water becomes dense enough to sink toward the seafloor. Once submerged, it can travel silently through the deep ocean for centuries before eventually rising elsewhere. Some water moving through this system may take hundreds or even over 1,000 years to complete its journey. In other words, parts of the ocean are carrying ancient climate information across the planet right now. That hidden circulation may be one of the most important systems sustaining modern civilization, and yet most people never think about it. Ocean currents regulate rainfall patterns, influence agriculture, shape hurricane intensity, and affect marine ecosystems on massive scales. Entire fishing industries depend on nutrient-rich currents rising from deep water. Civilizations historically flourished or struggled partly because of how oceans distributed heat and moisture across the earth. And sometimes, when those patterns shift, the consequences become dramatic. Every few years, warm water spreads unusually across parts of the Pacific Ocean during an event known as El Niño. At first glance, the temperature changes may seem small, but their effects ripple outward across the planet. Rainfall patterns shift. Some regions experience floods, while others suffer droughts. Fisheries collapse temporarily as nutrient systems change underwater. Storm tracks move. Even economies can feel the effects. The opposite phase, La Niña, alters weather differently again, often strengthening hurricane seasons in the Atlantic while cooling parts of the Pacific. What makes these cycles fascinating is that the ocean is not simply reacting to weather. It is actively helping create it. And the deeper researchers investigate these interactions, the harder the planet becomes to simplify. Earth's climate is not controlled by one thing. It emerges from countless moving systems influencing each other continuously. But the ocean may be the largest hidden force among them all, because water stores heat extraordinarily well. The atmosphere changes quickly. Oceans change slowly. That slowness gives currents incredible long-term power. There are places in the ocean where these hidden systems become visible in unsettling ways. Off the coast of South America, cold, nutrient-rich water rises from the deep through a process called upwelling. These waters support some of the richest marine ecosystems on Earth, attracting enormous schools of fish, seabirds, and predators. But during major El Niño events, warm surface water can suppress this upwelling. Fish populations decline rapidly. Entire food chains become disrupted. Seemingly distant climate shifts suddenly affect real human communities dependent on the sea. And then there are the ocean deserts. At first, the phrase sounds contradictory. Oceans seem endless and full of life. But huge regions of the sea contain surprisingly little biological activity because currents isolate nutrients far below the surface. In these areas, the water can appear calm, blue, and beautiful, while supporting relatively little life compared to nutrient-rich coastal zones. Some scientists compare them to underwater deserts drifting across the planet. Other regions behave even more strangely. In certain locations, large bodies of water resist mixing fully despite sitting directly beside one another. Differences in salinity, temperature, and density can create visible boundaries where distinct water masses meet. Satellite imagery sometimes reveals enormous swirling eddies spinning through the ocean like atmospheric storms. Some currents form loops large enough to trap heat, nutrients, or pollution for years. The Sargasso Sea may be one of the strangest examples. Located in the Atlantic Ocean, it has no true coastline. Instead, it is defined by surrounding currents that trap floating seaweed and debris within a relatively calm region. For centuries, sailors described drifting through vast mats of golden-brown sargassum algae under still winds and silent skies. Early explorers feared becoming trapped there permanently. Today, scientists recognize the area as an important ecosystem supporting eels, turtles, and countless marine organisms. But it still feels strangely isolated, like an ocean hidden within another ocean. Deep beneath the surface, currents continue moving through darkness, almost completely unseen. Some deep water flows creep along the seafloor incredibly slowly, carrying oxygen and nutrients into abyssal regions where sunlight never reaches. Without those currents, parts of the deep ocean might become stagnant and unable to support much life. The ocean's hidden circulation acts almost like a planetary heartbeat, distributing energy through darkness continuously. And yet, scientists increasingly worry about how stable that heartbeat really is. As polar ice melts and large amounts of fresh water enter the North Atlantic, some researchers fear parts of the global circulation system could weaken over time. Because saltier water sinks more easily than fresh water, major changes in salinity may affect how deep water currents form. There is ongoing debate about how severe such disruptions could become, and scientists remain cautious about dramatic predictions. But evidence suggests the system has shifted before in Earth's history. Ancient climate records preserved in ice cores and ocean sediments indicate that parts of the circulation system may have weakened or reorganized during past climate transitions. Some of those shifts happened surprisingly quickly on geological timescales. Temperatures in certain regions changed dramatically within decades rather than thousands of years. That possibility unsettles researchers because it suggests Earth's climate system may contain tipping points that are not fully understood. The ocean also remembers storms long after humans forget them. Heat stored beneath the surface can strengthen hurricanes dramatically if conditions align correctly. Warm ocean water acts like fuel for tropical systems, allowing storms to intensify rapidly. In recent years, scientists observed hurricanes strengthening faster than expected in some cases, partly because unusually warm ocean temperatures provided additional energy. Again, the sea operates less like a passive environment and more like a hidden engine, constantly feeding the atmosphere above it. For ancient sailors, currents often meant survival. Long before modern engines existed, civilizations learned to navigate using predictable ocean flows. Polynesian navigators crossed enormous stretches of the Pacific Ocean using currents, wave patterns, stars, and subtle environmental signals that many modern people would barely notice. European trade routes later depended heavily on understanding Atlantic circulation. Ocean currents quietly shaped exploration, trade, migration, and even empires. And despite centuries of study, many parts of the system remain surprisingly mysterious. Deep currents are difficult to monitor continuously because the ocean is vast, dark, and constantly changing. New satellite technologies and underwater sensors improved understanding enormously. But researchers still discover unexpected interactions between atmosphere, ice, and ocean circulation. The more data scientists collect, the clearer it becomes that Earth's systems are deeply interconnected in ways that resist simple prediction. Perhaps that is what makes ocean currents feel almost haunting when viewed from a larger perspective. Beneath every storm, every drought, every coastal fog bank, every fishing migration, and every shifting season, unseen rivers of water are moving quietly across the planet. Some have traveled for centuries. Some carry warmth from the tropics toward frozen seas. Others creep invisibly through darkness beneath miles of water. And while most people sleep unaware of them, these currents continue shaping the future of Earth every single night. Long before human beings stood on coastlines staring out at the sea, the oceans already belonged to predators so strange and enormous that modern Earth would barely recognize them. The prehistoric ocean was not calm, blue, or familiar. It was violent, unstable, and filled with creatures shaped by hundreds of millions of years of brutal evolution. Some hunted with jaws large enough to crush bone effortlessly. Others grew armored shells thicker than steel plates. Entire ecosystems rose and disappeared beneath ancient waters, while continents themselves drifted slowly across the planet. And perhaps the strangest part is that the ocean has always been more dangerous than the land. Even today, the deep sea hides animals humans rarely encounter directly. But in prehistoric oceans, danger existed almost everywhere. The water itself often carried less oxygen than modern seas. Temperatures shifted dramatically during different eras of Earth's history. Volcanic activity reshaped marine environments repeatedly. Entire species vanished during mass extinctions, only to be replaced by even stranger forms of life later. The prehistoric ocean was less like a stable environment and more like a constantly changing battlefield, where survival favored anything capable of adapting quickly enough. One of the earliest reminders of how ancient the ocean truly is comes from sharks. Sharks existed long before dinosaurs appeared. In fact, sharks are older than trees. That sounds almost impossible at first, but fossil evidence suggests primitive shark ancestors swam through Earth's oceans over 400 million years ago, during a time when forests had not yet spread across land. The world looked profoundly alien then. Much of the planet's surface was still barren rock, while the oceans already contained complex predators moving silently through ancient seas. And those early oceans were filled with creatures unlike anything alive now. During the Cambrian period, over 500 million years ago, evolution accelerated in what scientists sometimes call the Cambrian explosion. Suddenly, marine life diversified rapidly. Strange, soft-bodied organisms drifted through shallow seas. Predators evolved eyes, claws, and armored shells for the first time on a large scale. Some animals resembled giant underwater insects. Others looked almost impossible to classify even today. One predator, called Anomalocaris, grew to impressive sizes for its era and hunted using grasping appendages near its mouth, dominating seas filled with bizarre early life forms. What makes these ancient oceans feel especially unsettling is how experimental evolution seemed during that time. Nature had not yet settled into familiar patterns. Body structures appeared and vanished. Some species developed bizarre arrangements of limbs or armor never seen again after extinction erased them. The ocean became a laboratory for survival. And then the predators became larger. Among the most terrifying prehistoric fish was Dunkleosteus, an armored predator living roughly 360 million years ago. Unlike modern sharks with rows of replaceable teeth, Dunkleosteus possessed massive, sharpened, bony plates capable of generating extraordinary bite force. Fossils suggest It may have been one of the apex predators of its time, hunting through ancient seas where few animals could challenge it directly. Its head alone looked more like a weapon than part of a living organism. But prehistoric oceans did not remain stable long enough for any creature to dominate forever. Earth repeatedly experienced mass extinction events that transformed marine ecosystems almost beyond recognition. Some of these catastrophes were so severe that the majority of ocean species disappeared. The worst known event, the Permian mass extinction, around 252 million years ago, may have wiped out over 90% of marine species. Volcanic eruptions, warming oceans, falling oxygen levels, and toxic chemical changes likely combined into a planetary disaster unlike anything modern humans have experienced. For a time, parts of the ocean may have become nearly unlivable. Scientists studying ancient sediments found evidence suggesting some prehistoric oceans turned dangerously depleted in oxygen. In certain regions, toxic bacteria capable of surviving low oxygen environments may have spread widely. Imagine seas where large marine animals struggle to breathe, while chemical conditions beneath the surface became increasingly hostile. The ocean itself may have partially transformed into an environment closer to poison than life support, and yet life returned. That cycle appears again and again throughout Earth's history. Catastrophe reshapes the oceans, then evolution rebuilds them into something new. After the great extinctions, reptiles eventually rose to dominate prehistoric seas. Some resembled giant crocodiles. Others evolved into streamlined hunters, perfectly adapted for underwater pursuit. One of the most famous was Mosasaurus, a marine reptile capable of growing to astonishing sizes during the late Cretaceous period. Unlike dinosaurs roaming land, mosasaurs ruled the oceans directly. Fossil evidence suggests they possessed powerful jaws, excellent swimming abilities, and diets including fish, turtles, seabirds, and even other marine reptiles. Their bodies evolved for efficient movement through water, transforming them into apex predators of prehistoric seas. And they were not alone. Plesiosaurs drifted through ancient oceans with long necks and paddle-like limbs. Ichthyosaurs evolved bodies resembling modern dolphins, despite being reptiles. An example of evolution independently arriving at similar designs because certain body shapes simply work well in water. Some ichthyosaurs grew enormous, approaching the size of modern whales. The deeper paleontologists study prehistoric marine life, the clearer it becomes that the oceans repeatedly favored gigantism. That pattern may partly explain why the idea of hidden sea monsters still feels believable emotionally. For millions of years, giant predators genuinely did dominate the oceans. Perhaps none became more famous than the megalodon. Although exact details remain debated, most scientists agree megalodon was a truly massive shark species living millions of years ago. Fossilized teeth, larger than human hands, continue astonishing researchers and museum visitors alike. Estimates vary, but many suggest megalodon may have reached lengths far exceeding modern great white sharks. It likely hunted whales and other large marine animals in warm, prehistoric seas. There is no scientific evidence that megalodon survives today. Modern oceans have been studied extensively enough that sustaining a giant hidden breeding population would be extremely difficult without stronger evidence emerging. But the popularity of megalodon theories reveals something psychologically interesting about the ocean. Human beings instinctively feel the sea could still hide enormous things because, historically, it once did. And prehistoric oceans contained dangers beyond predators alone. Sea levels changed dramatically over geological time. At certain periods, shallow inland seas flooded huge portions of continents. North America itself was once partially split by ancient waters teeming with marine reptiles and enormous fish. In other eras, volcanic carbon dioxide warmed the planet significantly, creating oceans far hotter than many modern marine ecosystems could tolerate comfortably. Some scientists believe ancient oceans may even have appeared different colors depending on chemical conditions and microbial activity. Certain periods possibly contained greener or darker seas due to changes in iron content, algae populations, or atmospheric chemistry. Imagine standing beside an ocean that looked visibly unfamiliar compared to modern Earth, a world where the water itself reflected an entirely different planetary system. And through all of it, evolution continued, testing increasingly survival strategies. Giant sea scorpions hunted through shallow waters hundreds of millions of years ago, some reaching lengths over 8 feet. Ancient ammonites drifted through prehistoric seas in spiral shells before vanishing during the same extinction event that ended the age of non-avian dinosaurs. Massive filter feeders evolved repeatedly because oceans rewarded any species capable of processing enormous amounts of food efficiently. Even today, blue whales survive partly because the ocean still supports gigantism better than land does. Water helps support massive body weight. Movement requires less energy than carrying enormous mass across solid ground. The prehistoric ocean simply pushed those advantages even further. But perhaps the most unsettling realization about prehistoric seas is how temporary dominance always proved to be. No predator lasted forever. No ecosystem remained stable permanently. Entire marine worlds disappeared repeatedly through extinction, climate shifts, asteroid impacts, or changing chemistry. The ocean rewards adaptation, but it also erases relentlessly. And despite all modern science, enormous uncertainties still remain about many prehistoric marine creatures. Fossils preserve fragments rather than complete realities. Skin color, behavior, social structures, migration patterns, much of it must still be inferred cautiously. Every new fossil discovery can reshape assumptions researchers held for decades. In some cases, paleontologists realized certain ancient predators were faster, larger, or more intelligent than previously believed. The prehistoric ocean remains partly mysterious because time itself destroyed most direct evidence. Somewhere beneath modern oceans tonight, layers of sediment still hide skeletons from worlds that vanished hundreds of millions of years ago. Ancient teeth rest buried beneath dark seafloors. Bones of marine reptiles lie trapped inside stone. Entire species wait undiscovered because nobody has excavated the right place yet. And maybe that is what makes prehistoric oceans feel so haunting compared to modern ones. The sea does not just hide living creatures, It hides lost worlds. Beneath today's calm waves rests the memory of oceans that once belonged to monsters, chemical chaos, mass extinction, and evolutionary experiments almost too strange to imagine. The deeper humanity studies those ancient seas, the clearer it becomes that Earth was never designed for comfort. For most of the planet's history, survival in the ocean meant entering one of the most dangerous environments life had ever created. The deeper scientists explore the ocean, the less it feels like Earth. At certain depths, familiar rules begin to disappear. Water behaves strangely. Light vanishes completely. Entire landscapes emerge that look less like underwater environments and more like scenes from another planet. There are places beneath the sea where boiling water erupts from the seafloor in total darkness, where lakes exist inside the ocean itself, and where strange chemical conditions allow creatures to survive in ways that once seemed scientifically impossible. What makes these places especially unsettling is not just their appearance. It is the realization that most of them remained completely unknown for almost all of human history. Entire ecosystems, mountains, valleys, and geological structures existed silently beneath the waves, while civilizations rose and collapsed above them without ever knowing they were there. One of the strangest discoveries in the deep ocean is the existence of underwater lakes and rivers. At first, the idea sounds impossible. How can there be a lake inside another body of water? But in certain parts of the ocean floor, especially around the Gulf of Mexico, extremely salty water seeps from underground deposits and collects into dense pools along the seabed. Because this brine is much saltier and denser than the surrounding seawater, it behaves almost like a separate liquid world. Small waves form along its edges. Shoreline-like boundaries appear between the layers. Submarines descending toward these pools often describe the visual effect as deeply surreal, almost like flying over an alien landscape hidden beneath the sea. And these lakes can be deadly. Animals that accidentally enter some of these brine pools may become poisoned or unable to escape because of the extreme chemical conditions. Researchers have found fish and crabs preserved along the edges, almost like warning signs surrounding a toxic lake. Yet, even there, life still adapts. Certain bacteria and specialized organisms survive around the edges, feeding on chemicals rising from beneath the Earth's crust. Again and again, the ocean demonstrates the same unsettling pattern. Even the strangest environments rarely remain empty for long. Far deeper down, another bizarre world emerges around hydrothermal vents. These cracks in the seafloor release superheated water loaded with minerals from deep inside the planet. Some vent fluids can exceed temperatures hot enough to melt lead. Yet because of the crushing pressure at those depths, the water does not boil normally. Instead, dark, mineral-rich clouds burst upward through freezing ocean water, like underwater smokestacks. When scientists first discovered hydrothermal vent systems in the late 20th century, the finding completely changed assumptions about life on Earth. Before then, many researchers believed nearly all complex ecosystems ultimately depended on sunlight. But around these vents, life thrived in total darkness. Giant tube worms taller than humans clustered around the heat. Pale crabs crawled across black volcanic rock. Strange shrimp gathered in swarms near toxic chemicals that would kill most surface life almost instantly. Instead of relying on sunlight, these ecosystems survived through chemosynthesis, a process where organisms derive energy from chemical reactions rather than photosynthesis. It forced scientists to reconsider one of the oldest assumptions in biology. Perhaps life did not require sunlight nearly as much as humanity once believed. That realization extended far beyond the ocean itself. Suddenly, places once considered lifeless, underground worlds, icy moons, dark alien oceans, seemed more scientifically plausible as homes for life. The deepest parts of Earth's oceans became models for environments elsewhere in the universe. And yet, hydrothermal vents are not even the strangest places beneath the sea. In some regions, divers and submersibles discovered enormous underwater sinkholes known as blue holes. From above, they appear as dark circular openings in shallow tropical waters. But descending into them reveals something deeply eerie. Light fades rapidly along steep walls plunging downward into darkness. Oxygen levels often drop sharply. Layers of water with completely different chemistry stack on top of one another like invisible barriers. One famous example, the Great Blue Hole near Belize, became globally known partly because legendary explorer Jacques Cousteau helped investigate it decades ago. Massive stalactites hidden deep inside revealed that the cave system originally formed above sea level, before ancient oceans rose and flooded it after the last ice age. In other words, some blue holes are drowned landscapes from a lost world, geological snapshots preserved underwater from a time when coastlines looked entirely different. Deeper still, certain underwater caves become almost impossible to navigate safely. Divers entering them often rely on guidelines because visibility can vanish instantly if sediment becomes disturbed. A single mistake inside a flooded cave system can become fatal within seconds. The ocean contains spaces so confined, dark, and disorienting that even experienced explorers describe them as psychologically overwhelming. And then there are underwater volcanoes. Most volcanic activity on Earth actually occurs beneath the oceans, hidden far from human sight. Entire mountain ranges continue forming silently underwater through tectonic activity. Lava erupts across the seafloor where plates separate, creating new crust continuously. Some submarine volcanoes eventually rise high enough to become islands. Others remain buried in darkness forever. What makes underwater volcanic systems especially fascinating is how they reshape ecosystems constantly. Fresh lava fields initially appear lifeless, black, and sterile. Then, gradually, bacteria colonize the rock. Small organisms follow. Larger creatures arrive later. Entire communities slowly emerge from what initially looked like a dead landscape. Watching this process underwater is almost like observing a planet rebuilding itself from scratch. But not all strange ocean places are violent. Some are unnervingly quiet. There are regions beneath the sea where oxygen becomes so scarce that few larger animals survive there at all. Scientists sometimes call these dead zones, though the term can be misleading because certain microorganisms still thrive inside them. In some cases, pollution and nutrient runoff contribute to these low oxygen areas. In others, natural geography and water circulation create isolated environments where oxygen replenishment happens very slowly. Descending into one of these regions can feel almost apocalyptic. Fish disappear, movement fades. The seafloor becomes strangely empty. It is not the dramatic violence of predators that makes these places unsettling. It is the absence of life where life should exist. And then there are oceans within oceans. In certain polar regions, dense cold currents sink into the deep sea and move across the seafloor like invisible underwater weather systems. Some scientists describe these flows as underwater waterfalls because cold, dense water spills downward beneath warmer layers. One of the largest known examples occurs near Greenland, where enormous volumes of water descend into the Atlantic depths as part of the global ocean circulation system. The scale of these underwater waterfalls becomes almost impossible to visualize. Some involve far more water movement than any river on Earth. Yet, they remain completely hidden from normal human experience. Perhaps one of the most visually surreal ocean phenomena happens at night, when entire sections of water begin glowing. In certain conditions, microscopic organisms called phytoplankton emit blue bioluminescent flashes when disturbed by waves or movement. Beaches suddenly glow electric blue beneath footsteps. Ship wakes ignite behind passing vessels. Storm waves shimmer in darkness like liquid light. For ancient sailors unfamiliar with biology, scenes like these must have felt supernatural. Imagine crossing a dark ocean centuries ago and suddenly watching the water itself begin glowing beneath your ship. Even now, the sight feels strangely unreal. And still, deeper parts of the ocean become stranger. Some trenches remain so isolated and difficult to study that scientists continue finding organisms adapted to conditions previously thought impossible. Certain microbes survive near toxic chemicals. Other creatures endure crushing pressure while living near freezing temperatures. The ocean repeatedly reveals environments that force biology to stretch beyond expectations. What ties all these places together is not simply danger or mystery. It is isolation. Most of these environments exist almost completely disconnected from ordinary human life. Sunlight never reaches them. Human eyes almost never witness them directly. Entire landscapes continue existing beneath the sea with their own chemistry, ecosystems, and rhythms, independent from the world above. And perhaps that is why these places feel so haunting emotionally. The ocean does not just hide strange creatures. It hides entire worlds operating silently beneath civilization. Somewhere tonight, beneath miles of dark water, volcanic vents continue erupting unseen. Toxic brine pools rest motionless along the seafloor. Strange organisms drift through underwater caves where no human has ever entered. Cold currents move through trenches deeper than mountains are tall. Hidden lakes wait beneath the ocean itself. The deeper humanity explores the sea, the more the planet begins to feel unfinished, as if enormous parts of Earth still exist beyond the edges of ordinary human experience, waiting silently in darkness below. For most of human history, the ocean was both a lifeline and a threat. It fed civilizations, connected continents, carried explorers into the unknown, and at the same time swallowed ships, erased entire crews, and reminded humanity again and again how fragile survival really was. Long before engines, satellites, or weather forecasts existed, people still crossed enormous oceans in wooden vessels barely strong enough to survive storms. Looking back now, it almost feels impossible that human beings managed to navigate the sea at all. And yet somehow, they did. One of the strangest things about early ocean travel is how little room for error existed. A wrong current, a damaged sail, or a week without wind could become fatal. Fresh water spoiled, food rotted, disease spread quickly in cramped conditions. Even relatively short voyages could turn deadly because the ocean isolates people completely once land disappears behind a horizon. Perhaps no ancient sailors understood this better than the Polynesians. Centuries before Europeans crossed the Atlantic regularly, Polynesian navigators traveled across the Pacific Ocean, one of the largest and most unforgiving stretches of water on Earth. They reached remote islands separated by thousands of miles, using no compasses, maps, or modern instruments. Instead, they studied stars, wave patterns, bird behavior, cloud formations, and subtle changes in the movement of the sea itself. To modern people raised with GPS, that level of navigation sounds almost supernatural. But Polynesian wayfinding was based on generations of careful observation. Certain wave reflections hinted at nearby islands hidden beyond the horizon. Birds flying at specific times of day suggested land was within range. Star paths became mental maps memorized across entire cultures. The ocean itself became readable to those who understood it deeply enough, and survival depended on reading it correctly. The Pacific could shift from calm beauty to deadly violence in hours. Storms formed rapidly. Navigation errors meant drifting endlessly across open water. Yet, Polynesian sailors managed voyages so advanced that some historians still debate exactly how they accomplished them with such consistency. What makes their achievements even more remarkable is that many voyages occurred in double-hulled canoes, made primarily from wood, rope, and natural fibers. Farther north, another culture learned to survive the ocean differently. The Vikings crossed brutal North Atlantic waters centuries before modern navigation technology existed. Their longships moved through freezing seas where fog, storms, and icy waves constantly threatened disaster. Unlike tropical Pacific voyages, Viking travel often meant enduring cold so severe that exposure alone could kill crews before they reached shore. Historians believe Viking navigators may have used multiple techniques to survive those crossings. Coastal landmarks helped when visible, but open ocean voyages required deeper understanding. Some researchers suggest they used the position of the sun combined with reflective crystals, sometimes called sunstones, to estimate direction even during cloudy conditions, though the full extent of this practice remains debated. Whether or not sunstones were widely used, Viking survival depended heavily on experience, memory, and constant adaptation to unpredictable seas. And perhaps that is what connected nearly all ancient sailors. they understood something modern society often forgets. The ocean does not care about confidence. For centuries, shipwrecks remained common because weather could overpower even skilled crews instantly. Rogue waves, hurricanes, hidden reefs, and shifting currents destroyed countless vessels long before modern forecasting existed. Entire fleets vanished during storms. Some disappeared so completely that historians know them only from written records. The sea also shaped human psychology in powerful ways. Sailors became intensely superstitious because the ocean created long periods of uncertainty mixed with sudden danger. Strange lights, glowing water, unusual animal behavior, or unexpected fog often became wrapped in mythology because people needed explanations for environments they could not fully control. Even highly experienced crews sometimes interpreted natural phenomena as warnings or omens, and honestly, from their perspective, that reaction made sense. Imagine spending weeks surrounded by endless water with no sight of land. At night, the ocean could become almost completely black, except for stars overhead and bioluminescent flashes beneath the ship. Storms appeared suddenly. Wooden hulls creaked constantly under pressure from waves. Every unfamiliar sound mattered. Human beings evolved primarily on land. The open ocean pushes the mind into a state of isolation few modern people ever experience. That isolation became even more dangerous during long trade voyages. By the age of exploration, European ships crossed oceans regularly, carrying spices, silver, textiles, and eventually enslaved human beings between continents. These journeys transformed global history, but often came with horrifying conditions aboard ships. Food shortages, disease outbreaks, spoiled water, and cramped living spaces killed enormous numbers of sailors before vessels even reached destination ports. Scurvy alone devastated crews for centuries. Caused by severe vitamin C deficiency, the disease weakened gums, caused wounds to reopen, and slowly destroyed the body during long voyages without fresh food. What makes scurvy especially tragic is that its cure eventually proved relatively simple: citrus fruits and fresh produce. But for generations, sailors died because the nutritional science behind the disease remained poorly understood. The ocean repeatedly exposed the limits of human knowledge in brutal ways. Whaling voyages revealed another side of ocean survival entirely. During the 18th and 19th centuries, whaling crews spent months or even years at sea, hunting some of the largest animals on Earth, using relatively small boats and hand-thrown harpoons. A wounded whale could overturn vessels easily or drag crews into freezing water. Yet, whale oil became economically valuable enough that entire industries formed around these dangerous expeditions. Some historical accounts describe encounters so violent they sound almost fictional. The most famous example may be the whale ship Essex, which was rammed and sunk by a sperm whale in 1820. Survivors drifted for months across the Pacific Ocean under horrific conditions. The story later helped inspire parts of Moby Dick, but the real event was arguably even more disturbing because it demonstrated how vulnerable humans remained against the sheer force of the sea and the creatures living within it. And still, people kept returning to the ocean. Trade demanded it. Exploration demanded it. Empires depended on it. The sea connected civilizations long before airplanes or railroads existed. Ancient Mediterranean cultures built powerful naval fleets because controlling maritime routes meant controlling wealth itself. The Phoenicians, Greeks, Romans, and later European colonial powers all understood that the ocean could make nations rich if they survived it long enough. But survival at sea never became truly comfortable. Even modern sailors describe a strange psychological effect after extended periods away from land. Sleep patterns shift. Isolation grows heavier. The constant movement of the ship changes balance and perception. Storms become deeply personal experiences because there is nowhere to escape them. On land, people can seek shelter. At sea, the storm surrounds everything. Perhaps that is why shipwreck stories continue haunting people centuries later. They remind us how quickly civilization disappears once the ocean takes control. A modern city feels permanent. A ship in open water feels temporary. And despite all technological advances, the sea still wins surprisingly often. Commercial shipping routes today are safer than ancient voyages. But storms, rogue waves, mechanical failures, and human error continue causing maritime disasters. Cargo ships crossing oceans still face conditions powerful enough to destroy steel structures. Sailors still disappear. Aircraft carriers and submarines still respect the ocean because even advanced technology operates within an environment humans were never naturally built to survive. Yet at the same time, the ocean remains essential to civilization. Global trade depends heavily on maritime shipping. Fisheries feed hundreds of millions of people. Underwater communication cables carry enormous amounts of internet traffic across the seafloor. Humanity became deeply connected to the ocean without ever fully mastering it. And maybe mastery was never really possible. The deeper history of seafaring is studied, the more it becomes clear that humans survived the ocean mostly through adaptation rather than control. Sailors learned currents instead of fighting them. Navigators memorized stars because there was no alternative. Cultures passed down survival knowledge carefully because mistakes at sea rarely offered second chances. Somewhere tonight, cargo ships still move through black water beneath distant stars, much like ancient vessels once did. Crews watch weather systems carefully while waves strike steel hulls in darkness. Far from shore, surrounded only by water, the modern world suddenly begins to feel very old again. Because despite satellites, engines, and global navigation systems, the ocean still carries the same truth it carried thousands of years ago. Human beings survive there only temporarily and always on the sea's terms. Even after centuries of exploration, advanced submarines, satellite mapping, and modern marine biology, the ocean still holds scientific mysteries that researchers cannot fully explain. Some involve strange animal behavior, others emerge from sounds recorded in total darkness beneath miles of water. And some mysteries are unsettling precisely because they challenge assumptions scientists once believed were reliable. The deeper humanity studies the sea, the more the ocean begins to feel less like a solved environment and more like a living system, operating according to rules we only partially understand. One of the most haunting examples is the phenomenon of whale strandings. For centuries, people have discovered whales beached along coastlines around the world, sometimes alone, sometimes in massive groups. Entire pods suddenly swim into shallow water, where their enormous bodies collapse under their own weight once stranded on land. Some survive briefly before rescuers attempt to refloat them. Others die slowly beneath the sun while the tide pulls away. And despite decades of research, scientists still debate exactly why this happens. There are theories, of course. Some researchers suspect underwater noise may interfere with whale navigation systems. Others point toward illness, geomagnetic disturbances, changing ocean temperatures, or social bonding behavior, where healthy whales follow disoriented leaders into danger. Naval sonar has also drawn significant attention because certain mass strandings appeared connected to military exercises involving powerful underwater sound. But no single explanation fully accounts for every event. That uncertainty makes whale strandings deeply unsettling. These are some of the most intelligent and socially complex animals on Earth, navigating entire oceans with extraordinary precision. Yet sometimes, for reasons not fully understood, they move directly toward death, and the ocean continues producing strange sounds no one expected. Far beneath the surface, hydrophones constantly record the underwater world. Some noises are immediately recognizable: earthquakes, shifting ice, volcanic eruptions, whale calls. But occasionally, researchers detect sounds so unusual that they trigger years of speculation. One of the most famous examples remains the bloop, an ultra-low frequency sound detected across huge distances in the Pacific Ocean during the late 20th century. At first, the signal appeared almost impossibly powerful. Some people imagined enormous unknown sea creatures hidden in deep water. Others suspected underwater geological activity unlike anything previously documented. Scientists eventually leaned toward ice movement near Antarctica as the most likely explanation, because similar sounds were later recorded in polar regions. Yet even after that conclusion became more accepted, the mystery left behind an important realization. The ocean is still capable of surprising science at a planetary scale. And sometimes the mysteries are biological rather than acoustic. Researchers studying marine communication discovered that certain whales can exchange calls across astonishing distances, potentially hundreds or even thousands of miles under the right conditions. Sound travels extremely efficiently underwater, transforming the ocean into a world shaped more by acoustics than visibility. But scientists still debate how some marine species process and interpret this information so effectively. Sperm whales, for example, produce complex clicking patterns believed to carry social information far beyond simple navigation. Some researchers even describe elements of whale communication as culturally transmitted behavior, because different groups appear to develop distinct vocal patterns over time. In other words, parts of the ocean may contain forms of communication systems humanity barely understands. And then there is bioluminescence. The deeper researchers explore, the stranger this phenomenon becomes. Entire species evolved the ability to generate light chemically, yet scientists still study why certain patterns developed the way they did. Some organisms flash defensively. Others use glowing signals to attract mates or lure prey. In certain conditions, enormous sections of ocean water illuminate at night because of microscopic plankton reacting to movement. But occasionally, sailors and satellites observe glowing ocean events far larger than normal bioluminescent blooms. Vast regions of water shimmer mysteriously across incredible distances. Some are now believed connected to rare bacterial activity, yet many historical reports remain difficult to verify fully because the ocean changes so quickly. Again and again, the sea reveals phenomena that science can partially explain while still leaving deeper questions unanswered. Perhaps one of the strangest unresolved areas involves the deep ocean itself. Researchers estimate humanity has explored only a small percentage of the seafloor directly. Entire trenches remain poorly studied. New species continue appearing regularly. Some scientists believe millions of marine organisms may still remain undocumented, especially microscopic life hidden beneath sediments or inside extreme environments near hydrothermal vents. And some discoveries seem to stretch biology itself. Certain microorganisms survive without sunlight, without oxygen-rich environments, and under pressures once considered incompatible with life. Others appear capable of entering states of near dormancy for extraordinary periods. Deep-sea ecosystems repeatedly force scientists to reconsider where life can exist and how resilient biology truly is. This becomes especially important when considering the possibility of life beyond Earth. If organisms survive around hydrothermal vents beneath crushing pressure and complete darkness, then perhaps hidden oceans beneath icy moons like Europa or Enceladus could also support life. In a strange way, studying Earth's oceans has gradually transformed into a search for universal biological principles. The deeper we explore the sea, the more the planet begins resembling a model for alien worlds. But some mysteries remain closer to home. In recent decades, scientists discovered expanding dead zones in parts of the ocean where oxygen levels drop so low that many larger marine species cannot survive there comfortably. Some of these zones occur naturally under specific conditions, while others appear connected to pollution, warming waters, and agricultural runoff entering coastal systems. What worries researchers is not simply their existence, but how rapidly some regions seem to be changing. The ocean absorbs enormous amounts of heat and carbon dioxide from the atmosphere, helping stabilize Earth's climate in the short term. But the long-term biological consequences remain deeply complex. Ocean chemistry shifts slowly, quietly, and often invisibly before effects suddenly become obvious in marine ecosystems. Coral bleaching may be one of the clearest examples. Entire reef systems can appear vibrant and alive one year, then pale and damaged after prolonged temperature stress. Scientists understand much of the underlying process, yet predicting exactly how marine ecosystems will respond over long timescales remains difficult because the ocean contains countless interacting variables. And perhaps the most unsettling scientific mystery is how much remains hidden beneath the seafloor itself. Beneath layers of marine sediment may exist enormous microbial ecosystems extending deep into Earth's crust. Researchers continue discovering evidence that life survives far below the ocean floor in conditions once thought sterile. Some microorganisms appear capable of surviving with astonishingly little energy for extremely long periods. That possibility changes the scale of the biosphere entirely. Life may not merely occupy Earth's surface. It may extend deep underground into environments humanity barely considered until recently. The ocean also affects the human mind in ways scientists still study carefully. Many people experience intense fear when looking into deep, dark water, a reaction often linked to uncertainty and lack of visibility. Some researchers believe this response may connect to ancient survival instincts because humans evolved primarily in environments where hidden predators posed danger. Yet others experience the opposite feeling: fascination, calm, even emotional awe while staring at the sea. Psychologists sometimes explore how oceans influence perception, attention, and emotional regulation. There is something about endless water that seems to affect human consciousness deeply, though exactly why remains partly subjective and difficult to measure scientifically. And perhaps that emotional ambiguity mirrors the ocean itself. The sea is calming until it becomes terrifying, beautiful until it becomes unknowable. Even with artificial intelligence, deep-sea robotics, genetic sequencing, and global monitoring systems, the ocean still resists complete understanding. Strange sonar reflections appear unexpectedly. Unknown organisms emerge from fishing nets. Massive ecological interactions unfold beneath the surface with only fragments visible to researchers above. The more science learns about the ocean, the more complicated the planet appears. Somewhere tonight, whales are communicating through darkness, across distances humans can barely imagine. Unrecorded species drift through trenches no one has explored directly. Strange sounds echo through deep water beneath storms and ice. Hidden ecosystems continue surviving far below the seafloor itself. And perhaps the greatest scientific mystery of the ocean is not any single creature, sound, or unexplained phenomenon. It may simply be the realization that Earth's largest environment is still only partially understood by the civilization living directly beside it. The ocean changes slowly enough that most people never notice it happening. A forest burns, and the damage is immediate. A city floods, and the destruction becomes visible overnight. But the sea transforms differently. Temperatures shift quietly over decades. Currents move slightly off pattern. Entire ecosystems weaken beneath the surface long before humans realize anything is wrong. And because most of those changes happen far from shore, deep underwater, or across enormous distances, the planet's largest environment is evolving in ways many people barely see at all. Yet the ocean is changing constantly. One of the clearest examples is temperature. The oceans absorb enormous amounts of heat from Earth's atmosphere, far more than most people realize. Water stores heat efficiently, which means the sea acts almost like a giant planetary buffer, slowing some atmospheric warming that would otherwise happen more rapidly over land. But that absorbed heat does not simply disappear. It remains inside the ocean itself. In some places, researchers now measure marine heat waves powerful enough to disrupt entire ecosystems. Coral reefs, which depend on relatively stable temperature ranges, become especially vulnerable during prolonged warming periods. Corals may appear colorful and solid from above, but they exist through delicate biological partnerships with microscopic algae living inside their tissues. When ocean temperatures rise too high for too long, those relationships begin breaking down. The coral expels the algae, losing both color and a major energy source. Entire reefs can suddenly turn pale white beneath clear tropical water. What makes coral bleaching especially haunting is how silent it looks. There are no explosions, no dramatic storms. A reef that once supported thousands of species simply begins fading beneath the surface, while most people on nearby coastlines continue living normally above it. Some reefs recover if temperatures stabilize. Others struggle for years. Scientists continue debating how different reef systems may adapt over long timescales, because coral ecosystems survived major planetary changes before. But the pace and scale of current shifts remain deeply concerning to many marine researchers, and coral reefs are only one part of a much larger transformation. Fish populations themselves are moving. As ocean temperatures change gradually, many marine species migrate toward cooler waters. Some fish now appear in regions where previous generations rarely traveled. Fisheries that supported coastal communities for decades sometimes decline unexpectedly as marine food webs reorganize themselves. The ocean has always changed naturally over geological time, but modern monitoring allows scientists to observe certain shifts happening within human lifetimes rather than across distant ages. The unsettling part is how interconnected everything becomes beneath the surface. Tiny plankton drifting through the ocean may seem insignificant, yet they help support entire marine food chains and influence global oxygen production. Small changes in water chemistry or temperature can ripple upward into larger ecosystems in ways difficult to predict completely. The ocean is not a collection of isolated environments. It behaves more like a single connected system, constantly exchanging heat, nutrients, carbon, and life itself. And quietly, the chemistry of that system is changing too. The ocean absorbs large amounts of carbon dioxide from the atmosphere. This process helps slow atmospheric accumulation somewhat, but it also alters seawater chemistry gradually over time. Scientists refer to this process as ocean acidification, though the water remains alkaline overall. Even relatively small chemical shifts matter because many marine organisms build shells or skeletons from calcium carbonate. Some researchers worry certain species may struggle increasingly if those chemical balances continue changing significantly. Again, the transformation is subtle. Nobody standing on a beach can look at the horizon and see acidification directly. Yet beneath the surface, marine organisms continuously interact with chemical conditions humans rarely think about at all. There are also places in the ocean where oxygen levels are declining. These regions, often called dead zones when severe enough, form through multiple pathways. In some coastal areas, agricultural runoff carries excess nutrients into the sea, fueling enormous algae blooms. When the algae die and decompose, oxygen levels can drop sharply. Fish either flee or suffocate. Other low oxygen regions develop more naturally because of circulation patterns and warming waters. What makes these zones disturbing is not only the loss of marine life, but how suddenly healthy ecosystems can appear empty. Areas once active with fish and movement become strangely silent beneath the water. And while these biological changes unfold, another transformation spreads almost everywhere across the sea. Noise. For most of history, the ocean was comparatively quiet, aside from storms, waves, volcanic activity, and marine life itself. But modern shipping introduced constant mechanical sound into many parts of the sea. Cargo vessels, oil exploration equipment, naval sonar systems, and industrial activity now create an underwater soundscape dramatically different from what existed centuries ago. Scientists studying whales increasingly examine how this noise affects marine communication. Many whale species rely heavily on low-frequency sound traveling across long distances underwater. But human-generated noise may interfere with those signals in ways researchers still do not fully understand. Some studies suggest marine mammals alter migration routes or communication patterns in noisier regions. It creates a strange possibility. Parts of the ocean may be growing louder for humans while becoming harder for marine animals to navigate naturally. And then there is plastic. One of the most unsettling realities about modern oceans is how deeply human material has entered marine environments. Plastic waste now appears from surface waters to deep ocean trenches. Tiny fragments called microplastics drift through seawater, settle into sediments, and enter food chains. Researchers found microplastics inside fish, seabirds, sea turtles, and even some of the deepest parts of the ocean ever sampled. What makes plastic especially troubling is its persistence. Storms, sunlight, and waves break larger objects into smaller fragments rather than removing them completely. The ocean does not simply erase what enters it. In many cases, it redistributes it endlessly. And yet, even here, the picture remains scientifically complicated. Certain marine ecosystems show surprising resilience. Some species adapt more effectively than expected. Conservation efforts restore damaged habitats in specific regions. Marine populations rebound under the right protections. The ocean repeatedly demonstrates both fragility and endurance at the same time, which makes predicting long-term outcomes extremely difficult. Perhaps nowhere is this uncertainty more visible than in polar regions. Arctic sea ice has changed significantly in recent decades, affecting ecosystems dependent on seasonal ice coverage. Polar bears, seals, walruses, and countless microorganisms evolved around rhythms tied closely to frozen oceans. But warming conditions alter those rhythms. At the same time, melting ice influences ocean circulation because fresh water behaves differently from salty seawater. Some scientists continue studying whether major circulation systems could weaken or reorganize over long timescales if melting accelerates significantly. Others caution that Earth's climate systems remain enormously complex and difficult to simplify into direct predictions. But nearly everyone agrees the ocean is not static. It is responding continuously to changing planetary conditions. And perhaps the most unsettling part is how hidden most of these transformations remain from daily human life. People standing on coastlines still see waves rolling onto shore, much like they always have. Sunsets still reflect across the water. Beaches still feel timeless. Yet beneath that familiar surface, temperatures shift, species migrate, chemistry changes, and ecosystems reorganize themselves quietly. The ocean often changes invisibly, until suddenly the effects become impossible to ignore. A fishery collapses unexpectedly. Coral reefs bleach across enormous regions. Storms intensify over unusually warm water. Coastlines flood during high tides that once seemed ordinary. These moments feel sudden to humans because we notice consequences faster than gradual trends. But the ocean had usually been changing long before anyone paid attention. At the same time, the sea remains astonishingly powerful and resilient. Marine ecosystems survived asteroid impacts, mass extinctions, volcanic catastrophes, and enormous climate transitions throughout Earth's history. Life adapts repeatedly in ways humans often underestimate. The challenge is that civilization itself depends heavily on relatively stable coastlines, fisheries, currents, and climate systems. Human societies evolved during a period of comparatively stable environmental conditions, and now the planet's largest system is shifting beneath us in real time. Somewhere tonight, coral reefs are glowing pale beneath warm water. Schools of fish are moving toward colder seas. Ice is breaking apart in polar darkness. Cargo ships are crossing oceans, carrying sound through deep water. Tiny plastic fragments are drifting through currents older than human civilization itself. And most people sleeping near the coast will never realize how much the ocean changed while they watched only the surface. Even after everything humanity has discovered about the ocean, the most unsettling truth may be how much still remains hidden. Satellites map coastlines. Submarines descend into trenches. Robotic drones scan the seafloor in darkness. Yet, despite all modern technology, enormous sections of Earth's oceans remain only partially explored. There are valleys no human has ever seen directly. Ecosystems still untouched by science. And entire regions where the sea floor remains little more than a rough outline on a map. And somewhere in that darkness, the future of ocean exploration is already beginning. For most of history, humans could only survive underwater briefly. Ancient divers held their breath and descended into shallow coastal waters, searching for pearls, sponges, or shipwrecks. Even modern scuba diving reaches only a tiny fraction of the ocean safely. Beyond certain depths, pressure becomes overwhelming. Darkness swallows visibility completely. The deep ocean remained unreachable, not because people lacked curiosity, but because the environment itself refused to allow easy access. That is finally beginning to change. Modern robotic submarines now descend into regions too dangerous for human crews. Some move silently through trenches for hours, while transmitting live footage back to the surface. Others collect sediment samples, map volcanic ridges, or search for unknown species drifting through black water. Artificial intelligence increasingly helps analyze enormous amounts of underwater data because humans alone cannot process it quickly enough anymore. And the more these systems explore, the stranger the ocean continues to become. Almost every major deep-sea expedition discovers something unexpected. new organisms appear in environments once thought nearly lifeless. Unknown microbial systems survive beneath the seafloor. Strange chemical processes emerge around hydrothermal vents. The ocean repeatedly forces science to expand its understanding of what life can tolerate. Researchers estimate that a huge percentage of marine species may still remain undiscovered, especially in deep environments rarely visited directly. Some scientists believe the number could reach into the millions if microscopic life is included. That possibility changes the emotional feeling of the ocean completely. It means humanity may currently share the planet with countless organisms never officially documented by science, and many of them may look nothing like surface life. Deep-sea evolution followed different rules. Creatures adapted to crushing pressure, near freezing temperatures, darkness, and isolation. Some species evolved transparent bodies. Others abandoned eyesight entirely. Certain organisms survive through chemical energy rather than sunlight. The farther exploration extends downward, the more Earth itself begins feeling alien. In some ways, the ocean may be the closest thing humanity has to another world without ever leaving this planet. That connection becomes even more fascinating when scientists discuss the possibility of extraterrestrial life. Moons like Europa and Enceladus likely contain enormous oceans hidden beneath thick layers of ice. Beneath those frozen surfaces may exist darkness, pressure, hydrothermal activity, and chemical environments surprisingly similar to parts of Earth's deep sea. In other words, every new discovery beneath Earth's oceans may also be teaching humanity how to search for life elsewhere in the universe. And yet, some of the greatest mysteries waiting underwater may not involve biology at all. Entire sections of human history could still rest beneath the sea. During the last ice age, global sea levels were dramatically lower than today because massive amounts of water remained trapped in ice sheets. Coastlines looked completely different. Areas now underwater may once have contained forests, river valleys, settlements, and migration routes used by ancient humans. As ice melted and oceans rose, those landscapes disappeared beneath the sea. Researchers already discovered submerged ruins, ancient tools, and drowned structures in several regions around the world. Some underwater archaeological sites preserve details remarkably well because cold, low oxygen conditions slow decay. It raises an extraordinary possibility. Future ocean exploration may uncover forgotten chapters of human history hidden beneath modern coastlines. And because the ocean preserves things differently than land, some discoveries may survive almost untouched for thousands of years. Shipwreck exploration already revealed how much history remains hidden underwater. Warships, merchant vessels, aircraft, and entire fleets continue resting silently beneath the waves. Some are preserved so perfectly that they resemble frozen moments in time. Others disappeared so completely that historians still debate their locations centuries later. The ocean has always hidden evidence effectively. That quality will likely continue shaping future discoveries. There is also growing interest in the ocean floor itself as a resource frontier. Deep beneath the sea lie mineral deposits containing rare metals used in modern electronics and energy technologies. Some companies and governments have explored the possibility of deep-sea mining operations targeting these materials. But this idea remains controversial. Supporters argue such resources may become increasingly important for future technology. Critics warn humanity still understands deep-sea ecosystems too poorly to predict the consequences of disturbing them at large scales. Many regions targeted for mining contain species barely studied scientifically. Destroying habitats before fully understanding them creates uncomfortable ethical questions. And perhaps that tension represents the future of humanity's relationship with the ocean itself. For centuries, people mostly feared the sea because it was dangerous. Now, humanity also fears damaging it because civilization depends on it so heavily. The ocean regulates climate, produces oxygen, feeds populations, transports goods, and stabilizes planetary systems in ways many people barely notice day to day. At the same time, the ocean continues resisting total human control. Storms still overpower ships. Tsunamis still reshape coastlines within hours. Entire currents shift gradually beneath the surface. Unknown species continue appearing unexpectedly. Even modern mapping projects regularly discover underwater mountains, volcanic structures, and ecosystems scientists never predicted. The deeper humanity explores, the less finished the planet appears. Some researchers believe future ocean cities may eventually become realistic in limited forms. Others imagine underwater laboratories, energy systems, or long-term habitats built beneath the sea. Technologically, parts of this future already exist in experimental stages, yet living underwater permanently presents enormous physical and psychological challenges. Humans evolved under open skies and stable gravity conditions, not inside pressurized environments surrounded by miles of dark water. Still, the idea persists, because the ocean continues pulling at human imagination in a way few places on Earth can. Perhaps that attraction comes from mystery itself. Most of modern life feels mapped, tracked, and explained constantly. The ocean remains one of the last environments large enough to hide genuine uncertainty. Somewhere beneath the surface tonight are places no human has ever entered directly. Unknown organisms continue living their entire existence beyond human observation. Geological processes reshape the seafloor silently in darkness, and future generations may look back at our current understanding of the ocean the same way modern humans look back at medieval maps: incomplete, fragmented, and filled with blank spaces. There is also a deeper possibility that continues haunting ocean science quietly. What if the greatest discoveries are not waiting in distant space, but beneath our own planet all along? The ocean already transformed humanity's understanding of life repeatedly. Hydrothermal vent ecosystems changed biology. Deep-sea organisms reshaped assumptions about survival limits. Ancient submerged landscapes altered views of early human migration. Unknown microbial systems beneath the seafloor continue expanding definitions of where life can exist. Every major step deeper into the ocean seems to reveal not certainty, but complexity. And maybe that is the real future waiting beneath the sea. Not a single giant monster or one final hidden city, but something stranger: the gradual realization that Earth itself is still far more mysterious than modern civilization likes to believe. Somewhere tonight, Robotic submarines are drifting through trenches deeper than mountains are tall. Unknown species are moving through black water, untouched by sunlight. Ancient shipwrecks rest beneath layers of sediment, while currents flow slowly overhead. Volcanic vents continue erupting in darkness. Entire ecosystems survive beyond ordinary human experience. And despite centuries of exploration, the ocean still feels less like a place humanity conquered and more like a frontier quietly waiting below us, vast enough to continue surprising the world for generations to come. Thanks for spending this time exploring the mysteries of the ocean with me tonight. If you enjoyed the journey, don't forget to subscribe and leave a comment below telling me what topic or mystery you'd like me to explore next. Wishing you a peaceful night, good luck, and a deep, relaxing sleep tonight.